My name is Daniel Sanchez, and I'm here to talk about investment on renewable energies in the United States, precisely by state. Okay, we're going to try to see and understand what is the connection between investment on certain renewable energies by state and its characteristics, such as economic characteristics, weather, political views, and such and such. So why are we doing this, right? Renewable energies, some of us love them, some of us hate them, but I mean, one objective thing is that it's actually increasing throughout the years. And this research could be useful for companies related to renewable energies and also energy investigation centers. Here are some graphs, all right? Wow, that's really blurry. Anyway, so our graphs can you can actually see how this is OECD and this is non-OECD countries. This is the, okay, I can barely read that. But anyway, this is the history part. All right, here's the projections. You can see years right here, and I'll tell them to you. 2010, 2020, 2030, 2040. Okay, it makes sense. It goes for 10 years and stuff. So, okay, so basically you can see here how the energy consumption by countries is almost the same in the OECD countries, but it's increasing. And it's going to increase even more in the non-OECD countries, which means they're going to have to import fuel, gas, however you want to call them, I don't really know the name, or either use other alternative and sources of energy. Also here you can see there's a graph of the billions of dollars invested on renewable energies in the whole world. You can see it increases, right? It slows a little bit on 2008, we don't know why, and then it kept on increasing. All right, so here we have a map of all the projects related to renewable, and not only renewable but alternative energy projects. We have colors. I try to make it simple, you know, since my English is not that good, I just try to make it like really graphic. So, all right, so we can see how all the projects are kind of clustered. They're not really dissipated or spread like evenly throughout the map. You can see how there's some clusters of, you get green here, green here, green here. There's a lot of orange here. The thing is there's some green on top of it, you know, but there's a lot of orange here. Other smaller projects related to either hydrogen, energy, hydroelectric, but basically the main ones that we're going to talk about here is one renewable energy project, which is going to be solar energy, and one energy efficiency project, basically energy efficiency. All right. So we're going to do this. We're going to run two different regressions, OLS regressions, as most of my colleagues here did, and for the renewable energy we have solar, and for the energy efficiency we're going to use energy efficiency, of course, the data. We got over 13,000 observations here. If you add up all the amounts, all the money invested in 2010 only, it goes up to $2.69 billion in the United States, both by public and private investors. We got data by county, but it was really hard to find the right-hand side variables by county for the whole country. So what we did was we merged them into states to make it a little simpler. We got 913 observations in the solar energy part, with a total of 126 million total, and energy efficiency, 5,579 observations. Simple stuff, you see? Signs and question marks. So basically, for the solar, that was my hypothesis, my expectation. We have GDP per capita. I would expect it was going to be positive in both solar and efficiency, of course. You know, if the country, if the state has more money per capita, it would be more likely to invest on renewable energies and any other investments. Also, I'm not from this United States, so I would guess, you know, the Democrats, of course, they're the cool ones and stuff, so they would invest more money in solar energy and energy efficiency programs. We'll see about that later. All right, forest area. You would expect, you know, if you're going to put solar panels, you don't want trees spread by them. You know, there's going to be shadow. There's no space. There's no actual room for you to set on the solar cells. About weather conditions and efficiency programs, I wasn't really sure how that was going to affect. You know, so I just put a question mark. I didn't really want to risk it and look stupid in front of everybody. So yeah, days of sun is of course positively correlated to solar energy. My hypothesis. Price of gas. Yeah, I was just guessing, you know. If the price of gas is expensive, I'm not going to buy a lot of gas in order to produce electricity. I'm going to just try to invest money on alternatives, you know, in order to not spend that much money. And inches of rain would have a negative influence in solar energy. These are the maps. Now you can see, you know, how clustered the orange is here. The green was covering before. And then you have Solar energy, for example, is spread all over the place, basically coasts, and right here, they love over here. We love it too, you know. So, and energy efficiency, you can see how clustered it is right here. It's amazing, you know, and also in the southeast of the country. I thought really, I mean, there's no way, you know, this is just by any chance this can be just spread evenly and stuff like that. There has to be some things that actually explain what's going on here, you know, why is clustered there and not spread all over the place in an anarchic way. So I ran the first regression, solar energy. I'm going to explain a little bit like you did, so it's pretty cool. Okay, so we got an R-square of 0.5%, base I 0.5. Basically, that's telling us that the regression is explaining around 50% of the variation. And then all these small, can everybody see this? You know, I know you want to see this. Okay, so basically, this is the regression we ran. R-squared 50%. It's not a bad regression, you know. All right, so let's talk a little bit about the variables, right? Inside variables. 2012, that's just GDP. Okay, let's just imagine this is GDP, because I didn't change the level. So okay, we're having a negative and somehow significant variable. Basically, what this was telling me, I was expecting that the GDP would be positively correlated to the solar investment in solar energy, but it turns out it's negative. And I tried to make some sense out of that. And I was doing some research on solar energy, and basically what's going on right now, we know there's a lot of improvements in solar energy, and the price of solar cells is going down lately. So you would expect also from that relation that countries with lower GDP would be more willing to spend money on this kind of renewable energies since they don't have as much money, and they're becoming cheaper. Sun, days of sun, it's not that significant actually. You got a bigger number here, which means that it's not going to be a significant right-hand side variable. Democrats, same thing. I was expecting, you know, Democrats, school people, they're going to spend a lot of money on that. You know, they're going to help us and stuff. They're not helping much. You know, really, it's not that significant. All right, first area. All right, first area. Negatively correlated, as we guessed. The more forests you have, the less room you have to actually put solar panels. And the more money you would invest in probably like biomass projects that will use some of the trees in the forest area, gas price positively correlated, pretty significant too. And inches of rain is positively correlated. That doesn't really make much sense, but I mean, it could be so many explanations for that. It could be probably it rains less days, but it rains way more in the days that it's actually raining. But yeah, that's it basically. For energy efficiency. That's the next regression we did. We explain a lot too, you know, it's really not that high, you know, it's 9%, but I mean, we don't have that many right-hand side variables anyway, but you explain 44% of the variation. What's going on here? Democrats, what are you guys doing? That's a negative value right here. Oh, okay. Okay, so basically, and this one is significant, you know, the other one was not as much, but this one is. This one's basically telling you, they're not going to invest any money on that, you know. So this is telling you that states where Republican governors are ruling, they're going to invest more money on energy efficiency programs. Other than that, we have forest, sun, and inches. All the three negative. Thank God I put the question mark. Seriously, because this is basically telling us that states that don't have that many natural resources, such as, of course, forest area, days of sun that they could use for solar energy, or inches of rain that they could use for millions of things, for hydro, electricity, and stuff like that, have to invest more money on energy efficiency programs. And gas price. Always the gas price. It's positive, correlated, you know, the more expensive the gas is, the more you're going to try to invest in alternative sources. Conclusion, gas price. Common in both regressions is gas price. Same thing I said, when the gas price is high, you want to look for some alternatives. We explained 50% of the investment, of the changes in investment in energy-related projects. But of course, I mean, as I said, 50% is not that good, but there's one thing that we can actually change to fix this problem. We don't have a time series. All the data we have is from 1 year. So hopefully, if we are able to find data from different years, we're going to be able to put them in the regression, so that way the regression can take into account past values and be able to correct further regression. Future work, as I said, we're going to try to make a panel, use data from different years, so the regression can adjust for the parameters, and look for other inside variables that were harder to actually find, but if we keep doing some research, we're probably going to be able to find them. Taxes on energy production, that's really important for alternative energy resources. Energy consumption per capita is also important. It's as much money if people barely use energy. Well, would you want energy, just to spare? No, not really. Then presence of sources of hydroelectric. For example, I was taking into account only the inches of rain in that state, but some states could be really dry and still have some rivers coming from other states that they could use for hydroelectric power. And other measure of political views. I was only taking into account the governor of that state and not county governments and other kinds of governments. And that's it. Thank you very much.